Okay, CS 4900 final demo. I'm Eric Nelson. This is LCA. And if you're not aware, LCA stands for Lightweight Checkers acronym. If I go ahead and run it here, what we have is a very minimal, lightweight checkers game. You're playing against an AI. Movement is done by clicking on the piece you want to move and then dragging it to the position you'd like to move. The AI here just moved into me. Obviously I don't want to take, because if I take, it'll just take back, and I think it'll have better position there, so I'd like to move this piece right here. And I did click and drag there, but the game didn't let me. That's an invalid move. Because it's a rule of checkers that I didn't know, and I don't think most people know, is that if you can jump over your opponent, you actually have to. You don't have a choice. So I have to jump there, so I think kind of takes an advantage there. The reason for that rule, I think, is just so that otherwise you could just have maybe like some really defensive strategies where you wouldn't take your opponent and instead you'd kind of make up those like diagonal lines. So I guess that's why that's a rule, but oh yeah, I had to take there, so then it just did a double jump on me. And it's going to make a king the next move. Right. You can kind of tell it's a king if you have this in full screen. And assuming there's not a lot of compression, I turned up the specular coefficient on these objects. Maybe it's down. Whatever makes it duller, I changed the specular coefficient to try and make these shadows more obvious, because the pieces are all uniform color. There's not any baked lighting. But I think it's decently easy to tell, at least if you're, maybe not in a video, but it's decently easy to tell that these, and the difference between these pieces. And I might have just said it and forgot, but yeah, that does flip over so you can see it's a king. So really interesting gameplay there. The AI moved up and then back down. And now it's gonna, since I moved into that corner, I can't move anywhere else. I have to take it, it's gonna take me back and take more of the center. The AI will continue not wanting to lose checkers. And I have no shot of winning this game. I can try and make a king over here. But the logic of the checkers here is done by actually done from a project I did in CS 2401, just to implement the logic of checkers. But that was to with a command line using like A through G and then 1 through 8 to pick your moves. And by the fact that the AI just moved into me like that is a pretty bad sign. That means I'm gonna get double jumped. I have to take back, and it's gonna take 3 of my pieces. So this game's pretty lost. But anyway, yeah, when you're moving with, like, say doing G6 to H5, since you're never really trying to win, because it's just so tedious to do that, you don't really realize just how bad of a game checkers is if your opponent's half decent at the game. But yeah, once you've had enough of checkers, you can click simulate here. I'll actually launch an ICBM at the board. And I hit the torso there. That's it. So in the code here, all input output is handled by checkers IO. Basically, checkers IO spawns a thread that then runs that old checkers code. That's all in this checkers folder. And the IOs, well, the input at least is taken from GLView new module, which I didn't rename, from the on mouse down and on mouse up functions. In like on mouse down and on mouse up, it just will take this x and y position and then use these utility functions y to car and x to car to translate that into, for example, G6 to H5. So it literally translates it to the like letter number positions that you would type into a command line. And then that's passed to checkers IO, which then passes it to the actual checkers class. And the way checkers IO does that is it has a get line that I actually went in and replaced all of the get lines that would normally get line from a terminal, from like a CN. But instead of taking it from standard in, it actually now takes it from checkers IO get line, which will just block until it receives an event. The output is actually done within checkers.cc. And I just replaced this display status function, and it just directly changes the positions and rotations of all the pieces. And it can do that because checkers IO is static, so all of its members are static, all of the world objects are static. And yeah, the reason I went through all this effort of not reading this code, because this isn't an API, so it's not super convenient to replace the C in and C out with a whole thread to handle that. But it has the longest if statement I've ever seen, so I really don't want to read this. This if statement actually goes across both my monitors, and that's not even enough. So yeah, I just didn't want to read that. That's what checkers IO is for. What's also nice about having checkers on its own thread is you can hear whenever a piece is moved, there's a clicking sound, and you can actually tell that there's a decent delay between the time that I make a move and the AI makes a move. That time the AI actually took a really long time. That was probably 300 milliseconds that the AI took right there. So having it on its own thread prevents that from like blocking the update loop. Oh, okay, I can actually double jump there. So yeah, that prevents like the game from hanging. Yeah, other major additions are of course ICBM. Physics and sound are all from previous projects there. NetSync is here, but NetSync isn't used. And I think that's it. Only other major change is building. I have a build Linux that if you clone the repository and run build Linux ISH on Linux, it should prompt you to install anything you need. Here we have package not found. It should it should prompt you to install anything you need, including making sure you have the right version of Boost. If you have these somewhere in a folder, you can just overwrite this so that it doesn't expect it to be installed on the system, like on a system level. But yeah, so I tested this on my laptop, just cloned the repository, ran the script, installed what it told me to. It doesn't automatically install them because it's kind of whack, and you'd have to use sudo for that. Yeah, and it just works fine. Because all the shared multimedia is here and everything, so you don't need the full after user modules path. But the problem is building for Windows, and I basically can't test the CMake list.txt for a couple of reasons. I don't want to get too into it, but like this is just for dealing with a stupid bug in assimp that's in that version of assimp that's in the Ubuntu 20.04 version of assimp. And then I also can't get SDL to work for some reason. Anyway, if you do try and run this on Windows, assuming that this is written correctly, because I don't even know if this is the right formatting, I think it is. It does expect these PhysX DLLs to be in the lib64, which are not right now. So you may have to add those if you want to clone this. But yeah, that's everything for this project. Thanks for watching.